Hello. This is a response to Anna and Genesis's question about the 1.3.2 extra practice. They wanted to know if I could do an example of using the law of sines, which I certainly can do, when there's only one angle given. Alright, so I'm going to tell my phone to be quiet. Okay, here we go. So you should know that the law of sines is useful for, actually in class tomorrow we'll talk about when can we use the law of sines. Angle, side, angle, side, what is it good for? But for those of you guys who are actually watching this video, let's give you a little treat here. So if you think about it, we have sine A over angle A equals sine B over angle side B, right? These are lowercase. Okay. Now, of course, there's also one more, but we only use two at a time. So and we could call either angle A and B. So let's just consider this situation. Oops, too much. Okay. All right. So basically, to solve an equation, we need to know we need to have only one unknown. So we need to know at least two angles and one side. So that would be two angles on one side. So if we have a triangle, let's see, A, B, C. This is side A, B, C. So if we know the angle A, we know angle B, and we know this one, then that's angle, side. All right. If we know A, B, and A, that's A, B, and A. That's still angle, side. Okay, what if we know A, and B? Then we know A, and side B. So that's side angle. Or we could say ASS, side angle. Okay, if we know, I want to cover every possibility. Let's say we know angle. Is that every possibility? Then if we're missing the angle A, we would know BBA. So let's put that in dark green. If we are missing the A, we know angle B, and we know BBA. That's still angle, side. So basically, it works for angle, side, and angle, side. Okay, so we've just figured out that angle, side works for, law of sines works for angle, side, and for angle, side. All right. Whoopsies. Let's go ahead and put white here. Erase all that good stuff. Okay. All right. So what do we have here? We have, this is a situation, a case of knowing the angle, the side, and the other side. So it does work for this one. Now remember, when we're proving congruent triangles, angle, side does not work. But we're not trying to prove congruent triangles here. We just want to know, if we know an angle and two sides, is there a way to know the others? Now, for those of you astute students, if you remember though, because angle, side does not determine a specific triangle, there can be more than one triangle with the same angle, side. That means there can be more than one right answer, which is why when we do the law of sines with this, we have to be careful. When we use the inverse sign, we have to be very careful. Okay? Okay, so that means, now it doesn't really matter which is your A and your B and your C. Okay, so I'm just going to arbitrarily decide this is my angle A, Or you know what? Let's just say this. Well, we basically know that using the law of sine, sine of angle x over the opposite side x should equal, because we know that this angle and the opposite side should equal sine of this angle, sine of angle z, over the opposite side z, which is over here. So which of these do we know and which of these do we not know? So what we already know, let's put in black. Sine of x, well, we know x is 92. So sine of 92 over side x is 15 equals, now do we know z? No, we do not. But we know little z is 7. But we do not know sine of z, and so we're just going to leave that in our color. Okay, so then I'm going to cross multiply and try to get this whole thing. Now, you cannot separate. This is sine of z, so keep this whole thing in parentheses. We're trying to get it by itself, okay? So we're going to have 15, right, times sine of z, and it's smart to write the 15 first, okay, equals 7 times sine of 92. Now, why is it smart to write the 7 first? Because if you write it like this, sine of 92 times 7, you might think it's sine of 927, or you might accidentally do 92 times 7 first, and that's not what you want to do. We did not mean sine of 92 times 7 and then sine it. You want to do 92, sine that, and then multiply that product or sine ratio by 7. So just be careful to write the 7 first for your own good. Okay, now remember I'm still trying to get sine of z by itself because we want to isolate that because we don't know what it is. So I'm going to go ahead and divide 15 on both sides. Okay, so sine of z equals 7 times the sine of 92 divided by 15. And I can use my calculator to calculate that. So I'm going to go ahead and do it on my calculator. See if you could do it on your calculator and get the same answer. Be careful with your multiplication. Where's my calculator on my phone? Here it is. Okay, so, excuse me. Alright, so sine, okay, I'm going to do 92 first. Sine of 92 is 0.9999. I'm going to multiply that by 7 and divide that by 15. And I got 0.46638, so I'm going to say 4. Okay? Okay, so note, my answer is not, because what am I looking for? I'm looking for z, and I'm not saying that z equals 0.446. I'm saying that the sine of z equals 0.446. So what I'm saying is, if there is a function machine that sines things, when I put in z, let's say the function is sine of x. Okay, when I put in something, I get this, I input an angle, remember, and I get out a ratio. So let's say the angle I put in is z, I get out the ratio 0.4664. But I want to know, that's good, but I want to know what angle I put in, what angle I have to put in to get this output. Well, how do you know, if you know the output, how do you figure out the input? You have to do the inverse. It's the reverse function, which is sine inverse. So if I do sine inverse, that is ugly. If I do sine inverse of x, so this way, if I put in a ratio, I should get out the angle. So if I put in a ratio 4664 and I sine inverse it, it will tell me my angle z. So what I'm going to do is, okay, so all of that, I hope that made sense to you, but another way to think of it is if sine of an angle gives you this ratio, if I sine inverse this ratio, this is way too low. If I sine inverse, let's see. If I sine inverse the ratio, oh my god. So I had to press second on my iPhone app, and then to get my sine inverse. The sine inverse of 0.4664 is 27.8 degrees in degree mode. Okay, and so that is my correct answer. Let's see. Yep, 27.8. Okay, so I know that this angle right here is 27.8 degrees. This angle right there. Okay. So, well, keep in mind though, that's not the entire problem. So I'm going to go ahead and erase this. All of that work was for us to find out. Okay, you wouldn't erase this, so I really suggest you do this assignment on another sheet of paper so you could have the appropriate enough, sufficient space. Okay, so we found the angle. Now, it's really easy to find the remaining angle because we know that the sum of the three angles in a triangle add up to 180, so 92 plus 27.8, right? Is 0.8 and then 0.9, 119, and then 180 minus 119.8 is going to be 0.20. So 60.2. Okay, and let me check. Yep, 60.2. So this missing angle right here, angle Y, is 60.2. So we found the three angles, we found two sides, and now we have one more side to find. Okay, and I'm just going to do it right here. The other missing side, well, you might be tempted to use Pythagorean theorem, but remember Pythagorean theorem only works for right triangles, and this is not a right triangle. So we can use the law of cosines or the law of sines, but since I asked you to use the law of sines, okay, so now we can say that, let's see. We can say that the sine, let's still use sine of x over little x equals sine of, now since we're trying to find out the side opposite from y, let's use sine of big Y over little y. Okay, sine of x is sine of 92 over 15 equals sine of, now this is a y, guys. Sine of y is sine of 60.2 over y, because this missing side is y. Okay, so then y, all you have to do is switch these guys, and you can do that. So y equals, if you do some cross multiplication, you should know that y equals 15 times sine of 60.2 divided by sine of 92 degrees. And if you find the answer on your calculator, you should get, okay, let's see, I'm going to do 60.2 first. Sine that divided by 92 and the sine of that, and then I multiply by 15. And I got y equals 13.024. Okay, and yep, 13 inches was the answer. Okay, I hope that helps. If you still have questions, let me know. But it turns out that we had to use sine inverse. If you only have one angle, you're going to have to use sine inverse to find one of the missing angles. Right? In order for us to find z, remember we had to know that the sine of z, because we used z because we knew the 7 opposite from it, so we used the original ratio, sine of this angle divided by this side equals the sine of this unknown angle divided by this known side. But if we have an unknown angle, to find that angle, we're ultimately going to have to use the inverse sine of that unknown angle to find the angle. Okay? Alright, message me if you have questions. Good luck!